Hello, everyone. I'm Jenny Stengel, the Senior VP of Education for the Self-Storage Association. Thanks for joining us for our next installment of our Spring Conference webinar series. Today, we have Matt Elmore of Pivot Energy joining us to talk about solar success, how to leverage solar energy systems to increase profit and property value at self-storage facilities. The session was originally created for SSA's Spring Conference, so before our new reality of dealing with the COVID-19 pandemic. But what Matt's about to share is certainly valuable to any self-storage operation, and it'll be particularly valuable when we get back to our new normal. So for now, I'll turn it over to Matt.
Good morning, everyone. Thanks for having me, Jenny. Really appreciate the opportunity to talk with everyone today about solar energy. Obviously, this is a pre-recorded session, but my contact information is on the last slide, and I think Jenny's going to give some information after I get done. But again, thanks for having me. I usually make this presentation in person, obviously, and I encourage questions throughout, so I probably won't need a ton of time here, but again, I encourage anyone who wants to learn more, is curious about solar energy, or has questions to contact me afterwards. So I'm Managing Director at Pivot Energy. We are a commercial solar energy company that does a lot of work with self-storage facilities. And I'm going to take you guys through the agenda, talk about what I'm going to cover today, and then we'll get right to it. So 4 main sections of the presentation. First is very brief company background, what we do, what other solar contractors do. Then we're going to talk about the technology behind solar PV, which is solar photovoltaics, PV for short. Then we're going to talk about the tax credits, rebates, incentives, the financial side of the picture, and then some case studies and what makes a good candidate for a rooftop solar energy system for self-storage facilities. So just briefly about Pivot Energy. So we are a turnkey commercial solar energy contractor, meaning we handle everything involved with solar energy installations from initial feasibility on to construction and commissioning. I am based in Denver, where our headquarters is, but we have offices and staff in St. Louis, Chicago, New York City, and DC. We've completed well over 300 solar energy projects across the country, coast to coast, north, south, you name it. We have experience all across the country and have done self-storage facility projects in a similar number of states. We focus on what we call on-site solar or behind the meter, meaning we do focus on reducing the electricity bill for self-storage facilities or really any commercial facilities. We also do community solar, which I'm not going to get into too much because it's not as applicable to as many customers. It's limited to only a few states right now, but I will mention that. And then we're going to talk a little bit about finance as well and what the options are for financing if you don't want to purchase a solar energy system with cash. So moving on to the next slide, this is a good amount of detail here on the development process for any on-site or rooftop solar energy system. And really those 5 stages are development, financing, engineering, construction, and management. There's kind of a limitless amount of information I could discuss in each of these, but I'll just touch on them briefly. Development is the initial stage, and really what that stage encompasses is feasibility, both from a technical and financial perspective. From a technical perspective, if you're looking at solar energy, we want to look at the roof of the building, the structural capacity of the building, the electrical service. Those are all really important pieces that help us determine the final cost and ultimately the technical feasibility of whether we can install at that site. From a financial perspective, this bleeds into financing, obviously. You've got a lot of work and diligence that needs to be done to accurately model the financial picture for each self-storage site. So that includes things like utility bill analysis, analyzing local incentives that might help reduce the cost of the solar energy system. There's quite a few pieces to that diligence, and that makes that step in the process that much more important. So once development is done and you decide, hey, I want to move forward, we focus on financing. The majority of our self-storage customers actually purchase systems with cash or CapEx funds. So financing actually isn't as big of a deal, at least so far in our experience with self-storage portfolio owners. But we have had quite a few that still utilize that. And financing, I'll get into a little bit more detail later, but there's quite a bit of information and process involved there. So assuming the first two steps go well, development and financing, then we go into kind of final system design and engineering. And then we submit for permitting and move into construction. The system is constructed, and then there's ongoing operations and maintenance that is an option post-construction as well. So our team at Pivot, we do all these services, but other solar contractors do as well. So it's important that when you're discussing feasibility of a project and are in the beginning stages of this, that you consider the capability of whichever contractor you're working with at all stages of the life cycle of the project. Just another thing touching on our experience. So again, there's on-site, which is what we're talking about with you all today, and then there's off-site, which is community solar. Community solar is different in that it's where there's a larger, often a ground mount solar energy installation that you are buying power from remotely, often at a savings compared to your current utility rate. I'm not going to dive into that too much. It's not available in that many states across the country, mainly the Northeast, Illinois, Colorado, Minnesota, and a few select other areas. So if you do have questions or are curious about that, please shoot me an email, but I'm going to stick with the on-site renewables for the majority of the presentation today. Just very quickly, a few of our customers, obviously some self-storage customers here, Extra Space, Safeguard. We have a number of other independent self-storage owners as well. And then we don't just do self-storage, we do a variety of commercial and industrial, as well as educational verticals as well. So a lot of universities, grocery stores, things of that nature. Okay, we're going to dive into the technical side of this. This is just a brief kind of solar energy 101. How does solar energy work? How do the panels work? How does the whole system work? And we'll go from there. So this picture here shows a typical building and a rooftop installation. You see a carport installation in the back, but basically this just shows the 4 stages or steps of electricity production from solar energy panels. So number 1, pretty basic. The sunlight hits the solar panels, the solar cells, and that produces electricity in the form of direct current or DC. That's important to note because as you move into step 2, the direct current electricity is converted to alternating current or AC electricity by the inverter. So it goes from DC to AC. Think about that, the opposite of the band. And it's required that we do that because the AC electricity is compatible with our electric grid. So if you are sending any energy back to the grid, then you are making it compatible with the grid. And that's an incredibly important piece of it that is done via the inverter. So once that's done, solar electricity flows into the building's electric panel and is either consumed on site if there's electricity consumption on site at the time, or it is sent back into the electric grid and consumed by the nearest energy consumer. I'll get into some of the incentives a little bit later, but the value that the electric utility pays you for any electricity you send back to the grid is an important consideration, and I'll touch on that a little bit later, but that's discussed on point number 4 there. So here are a few examples of just what a solar energy installation looks like. I imagine people viewing this right now have seen them on homes or maybe in fields somewhere, but just wanted to give you an idea of some actual installations we've done. This is an extra space storage facility in the Chicago area, and this is on a flat roof with a TPO, a white TPO roof that's relatively new. And these panels just sit on top of the roof. I'll get into the racking systems that hold the panels down in a second, but this just shows you what it looks like. And this offset actually nearly 100% of the energy consumption at this facility, and you can see we didn't even need all of the roof. So plenty of roof space for the majority of self-storage facilities to offset almost all of the energy consumption on site. This is an example of a metal roof application. Metal roof applications are often or most frequently done via a flush mount system. So you can see this roof is more or less flat. It has a slight tilt to it, but those panels, instead of being propped up like I showed in the last photo, I'll just go back to it real quick. These are propped up at a 10-degree angle facing due south, and this is obviously flush with the metal roof, and that has to do with the type of attachment that we use to connect to the metal roofs. So those are the two most common options for self-storage facilities. Obviously, there are metal roofs that are pitched, and we can connect to those as well, but that's probably what we see in 90% of our installations for self-storage customers. A few other examples, just in case you're curious. This is actually a ground mount installation we did for a university, but this is kind of typically what you would see for what we call fixed tilt ground mount. This probably isn't very applicable for the majority of self-storage facilities, but it might come about if you've got land next to your facility. Another application here are solar carports. This is a carport installation we did at a MasterCard data center in Missouri, and this is definitely something to consider for self-storage facilities. They do cost more than the rooftop just because you have to build the structure itself instead of just laying it on top of an existing roof, but there's obviously additional benefits, shade, protection from rain, snow, all of that. So certainly we do see a good number of self-storage owners who want to look at carports and consider investing in them. So diving in now from the kind of bigger picture system down to the specific components of the system, we've got solar panels and inverters, which are the most expensive portions of the most expensive components of the solar energy system. Solar panels, there's 4 or 5 things that are really important to note about them. I think everyone probably has seen them at some point in person, but no matter who you source your solar panels from, as long as it is a high quality, what we call tier 1 manufacturer, the warranty is going to be for 25, sometimes 30 years. And what that warranty basically says is that by year 25, this panel will be producing 80% of what it produced in year 1. So while there could be better panels in the future that are more efficient, that's very likely, these panels don't degrade that much. It's approximately 0.5% a year that they lose in their production value. And so you're still getting the vast majority of production in year 25. And that just goes to show that these aren't going anywhere. This is a very reliable technology, and barring an earthquake or a tornado or a massive hailstorm with softball size hail. These things are going to be on the roof for a long time and reliably producing electricity for the majority of their life. Most panels, or I should say all panels, are hail resistant, but they are, that's up to a point. Kind of quarter size hail is I think what most can withstand. But again, personally, I'm from Oklahoma, where when I grew up, I saw softball and baseball size hail pretty regularly. That's going to damage the panel, and that would need to be replaced in that circumstance. But other than that, there's very little maintenance and super reliable and quite frankly, relatively boring in the best way possible, in that they're not going anywhere, like I said, and they'll continue to produce electricity for as long as we need them to. The other component, as I mentioned earlier in the first slide in this section, was the inverters, which produce AC electricity, which is grid compatible or electric grid compatible. These are similarly reliable, but they are probably the most likely component of the system to need to be replaced. We usually assume there's an inverter replacement needed in year 15, but there are warranties. Kind of minimum is 10 to 12 years, and you can extend the warranty on to 20 years. And these are installed either on the roof near the system or in the electric room or by the utility meter. The picture I have is a little bit larger in proportion to the actual panel than I think it is in person, but this is the size of slightly larger than a utility meter, and there's usually multiple inverters required for each system. So it does take up some wall space, but it's not a huge amount of space necessary. Okay, so moving on to the other important component of a solar energy system is the racking. This is what holds the panels down to and attaches them or weighs them down to the roof. And really, for I would say 95% of self-storage facilities, one of these two racking systems is what we would utilize. The first one is what we just call a ballasted system. That's the photo on the left. And that is basically just a system that sits on top of the roof membrane. It is weighed down by basically fancy cinder blocks, for lack of a better term. And in the vast majority of circumstances, there are no roof attachments or penetrations required. This is really important. We don't want to penetrate the roof ever, and that's always the goal. It's not always possible. Oftentimes, for example, in California, because of earthquake requirements or earthquake mitigation requirements, that we do have to attach the roof. So it's not the end of the world, but we generally assume that we won't have to attach the roof, and that's good because it guarantees that the roof membrane warranty will not be voided at all. So like I said, it's very rare to have from a structural perspective, attachments to the roof, but it could come about. The other option is on the right side here is a standing seam, which is a metal roof. There's two types of metal roofs really that are predominantly installed in the United States. One is standing seam, the other is corrugated. Standing seam is more expensive, and that's what we see on the vast majority of self-storage facilities. And the clip we have here is called the S5 clip, and it does not penetrate the roof at all. It clips onto the ridges of the standing seam roof and does not void the roof warranty. We've never seen it void it. And it just clips onto the ridges. So that's a super simple solution. Unfortunately, if you have a corrugated roof, those are not as much ridges as like mounds on top of the metal, and so there are racking systems that are available for those, but there's a slightly higher likelihood of leaking. So we try to avoid installing on corrugated roofs, though it is possible. So those two are the most common racking systems. There are kind of quite a few variations to those, but just something to note that this is the most common ones we see. Okay, so the last piece, which I haven't mentioned yet, that comes with all of our solar energy systems are remote monitoring capabilities. So this is just basically a Wi-Fi, usually Wi-Fi enabled, though it can be cellular enabled as well, monitoring platform that shows real-time energy production from the system. So you could look at it every 15 minutes across the course of a single day, or you can look at production over the course of a year or longer. Most of these systems, this is kind of a common dashboard that we have, but most of these systems will show, equivalencies as you see on the bottom here, like this this energy generation is equivalent to so many trees or carbon dioxide reduced, things like that. So this is something that some of our customers, quite frankly, don't care about. Others really do care about it, though, and they put this on their website or they put it on a TV in their sales office. There's a variety of ways you can use it to promote it. But this also has another function, a dual function of letting us know if there are any issues, say, with an inverter or some other thing that might have happened to the system, which is pretty rare, but this notifies us and the owner if something occurs of that nature. Okay, a few other considerations related to equipment and the technical side of things. These are mainly in consideration of new construction. So if someone comes to us and says, hey, we have a building or buildings that are in the design phase, like I want to put solar on them, but I don't really know what to consider and talk with my design team about. There's really 4 pieces to this. I'll actually start with structural. So structural, it basically means if we put this extra weight on the roof, is the building going to collapse? It's more complicated than that, but that's the easiest way to understand it. Generally, solar energy systems add between 4 to 5 pounds per square foot. And it is rarely an issue for a variety of construction types, building ages. We rarely see an issue. I would say less than 2 or 3% of buildings need structural enhancement to be able to hold the solar energy. So for new construction, I wouldn't expect that to be an issue, but you have to communicate that to the structural engineer you're working with to make sure they take that into account. Another thing is electrical. You're going to connect, if it's a rooftop system, the solar PV system down to the electrical system, which is often on the first floor. And so designing in conduit runs from the roof down to the bottom can save a few $1,000s, and that's something that you definitely want to consider. And then, as I mentioned on the previous slides, in relation to roofing, the ideal scenarios are a TPO, a white TPO roof, if it's a flat roof, or a standing seam metal roof if it's a pitched roof. Either of those are going to result in the most cost-effective installation. That doesn't mean that if you have another type of roofing situation or a unique roof that we can't install it, but those are the ones that are almost certainly guaranteed to make solar feasible. The only other consideration that you want to think about as it relates to new construction is energy consumption. So in most states and utility territories, you can't just put a solar energy system on your roof that produces 5 times as much energy as you consume over the course of a year. There are rules to how big your system can be in relation to how much you consume. And this is why it's important for new construction, since you don't have a history of energy consumption on site, to either wait until post-construction and get 3 to 6 months of energy use so you know, or to complete a relatively detailed energy model, which a group like Pivot could help with, to make sure that you're accurately sizing the system and not oversizing it, because then you're just effectively sending electricity back to the utility for free or at a very low compensation rate. So that's an important consideration, slightly different than the technical ones, the other 3 technical ones, but certainly something worth noting. Okay, so we covered a lot of the technical considerations, certainly not 100% of them, but the majority of the ones we see and the ones we see most frequently. Now we're going to switch over to a few slides on tax credits, rebates, and other incentives. These are really important and are pretty frequently available for customers who we work with. They vary greatly by state, utility territory, municipality. There's a lot of different things that you have to consider, and that's really our job, or whichever solar contractor you work with. It's their job to help you understand all these and make sure you get as many tax credits, rebates, and incentives as are available to you. So I break these down into a few different layers. The first one being the federal incentives. So the big one that has been in existence for a number of years now, I think more than a decade, is the federal investment tax credit. This is a tax credit provided by the federal government that currently for this year, 2020, is equivalent to 26% of the total system cost. So if you had a system cost $100,000, you would get 26% of that back in the form of a tax credit, so $26,000. That is only usable if you have tax liability, right? It's not technically refundable. I'm certainly not a tax lawyer. You need to consult your CPA and internal staff on this, but as long as you pay taxes, in that scenario, more than $26,000, you can benefit from this. Though you don't have to take it in year one, it can be taken in future years. The one notable thing about this is that, for better or worse, this tax credit is decreasing in value. So next year, it'll only be valued at 22%, and then it goes down 12% down to 10% in 2022 and beyond. We are trying to get this extended so that the rate does not go down and it hovers at 26% or higher, but that's not guaranteed. So there is some urgency there that if you want to consider solar, you don't want to wait a couple years. Any potential cost reductions that would occur in those years will likely be offset by a lower tax credit. So you really want to take advantage of that as quickly as possible. The other federal benefit is that solar energy equipment is eligible to be depreciated 100% in the first year. So it basically has a year one 100% expensing option. Not everyone can utilize depreciation, but if you can, it adds up to a good chunk of change for customers that we work with. And I would say the vast majority of them are aware of this and utilize that benefit. So that's the federal case, and those are really the only federal incentives that exist that are widespread and universally applicable. But there are, I would say, hundreds of other incentives across the United States that come in the form of what we call solar renewable energy credits, rebate programs, tax exemptions, and net metering. I'm not going to dive into these in a ton of detail because it would just be impossible to summarize them. But I'll just say that solar renewable energy credits is basically the idea that some entity, a government, a company, or someone else that has a renewable energy goal or requirement is essentially paying you for the solar energy you produce. And that's what an SREC or solar renewable energy credit is. That is, each SREC is equivalent to 1,000 kilowatt hours. And every state has a different SREC program, if they have one. Not all do, but if they do, they have a different SREC program, and the value of that SREC is dependent on how aggressive their renewable energy requirements are. So that's why I can't really summarize them because there's so many different ones, but that is absolutely one that is very common, especially in many of the northeastern states, Illinois, Colorado. There's quite a few that have the opportunity or offer the opportunity to sell those to a buyer. In addition to that, you've got what we call rebate programs or cash rebate programs. That's simply once you finish the system, there's a cash check given to you by the utility in most circumstances. That is basically to help reduce the upfront cost of the program. Again, those vary across the country, but are somewhat widely available. And then there's the final two here, tax exemptions. So there's a lot of sales tax and property tax exemptions. So property tax, for example, would be the taxing authority where you are will not increase your taxes based on the increased property value of your solar energy system. That's relatively common. There's often sales tax exemptions. There's a state sales tax exemption, for example, in Colorado. So that just helps reduce the upfront cost of the system to the customer. And a number of other tax-related exemptions exist, but those are the two big ones and ones that we catalog for our customers. The final incentive is net metering. I mentioned this earlier when I showed the picture of the building and the Solar Energy 101. Net metering is the idea that if you send electricity back to the grid and you sell it back to the grid, you are paid the same amount by the utility as what the utility charges you. That's the most basic definition of net metering. There's a bunch of different iterations of it across the country, and it varies by utility in many circumstances. But if a net metering policy like I described exists, that's a good thing, because that means that if you're sending any electricity back to the grid, you're being compensated at the same rate as which you're charged. There are a lot of utilities that pay you significantly less, sometimes 20, 30% less. Or even 70, 80% less than what they are charging you. So it's important to note that. And that's, again, all of these incentives, federal, state, local, utility, are something that we as Pivot provide to our customers. That is absolutely something that any solar energy contractor should guide their customers on and inform them on to make sure they're getting the best value for their system. Okay, I'm going to move on to finance models, and I'm not going to dive into this too much because similar to incentives, finance models can get pretty hairy. But I did want to note them and note that they are doable. We've had a number of customers utilize these financing arrangements for self-storage facilities. So I want to touch on each of them briefly. The first one is just cash purchase CapEx, and like I said before, that's the majority of our customers. They use money, their CapEx funds or cash they have to purchase the system outright, and then there's a return on investment they achieve. That's the most basic, and it's not really a form of financing. But number 2, 3, and 4 are definitely financed agreements. These are all where a third party owns the system for a set amount of time, and there is no upfront cost to you as a facility owner. And the goal with all, well, at least with number 2 and 3, is that the payments you make to the financier each month are less than what you're saving on your utility bill. So there are situations where these make a lot of sense, where if you don't have enough cash to purchase a system up front, but you want to invest in solar and ideally save some money, you can use a power purchase agreement or an operating lease to reduce your operating costs at your facility. They're different in how they're structured, but they're essentially offering the same value proposition in that you are reducing your operating costs with no upfront cost yourself. So it can be a win-win situation. It doesn't work in all areas, and it's best in areas like California and the Northeast, where there are high utility bill costs, and then we can more often provide a proposal for those financing options that saves our customers money. The fourth option is pretty unique. I mentioned on here Massachusetts and Los Angeles. There are a few select other areas around the country where you can do this, but it's pretty unique, and I don't want to get people too excited about it because it's unless you have facilities in these areas, you won't be able to do it. But a roof lease is essentially a scenario where you are paying the financier is paying you to lease your roof, and they are covering your entire roof with as much solar as they can and sending that electricity back into the grid. And the utility, the local utility, is then paying them a set rate per kilowatt hour per unit of energy for that over usually 10 to 20 years. These can be highly lucrative for self-storage owners because there are, like I said earlier, there are large rooftops that are not utilized. And there's a lot of space in the rooftops. So these can often result in payments of, $25,000, $50,000 or plus dollars a year that don't require any cost up front. So if you do have facilities in these areas, Massachusetts, Los Angeles, absolutely worth considering. But for customers that don't have facilities in those areas, unfortunately, that's not an option you can utilize. Okay, moving on here, we're going to talk about a few more specific pieces to return on investment and financial metrics. So this may have already occurred to you, but there's some pretty straightforward scenarios here for the financial benefits of solar energy. Obviously, our goal in the majority of scenarios is to reduce the electric utility bills on site to as close to zero as possible. You can't always get to zero sometimes, but our goal is to reduce it as much as possible. So reduced operating costs equals more profit, right? It also, for a lot of self-storage owners, utility bill savings also equates to added property value. So we know that a lot of self-storage owners flip properties or they sell them frequently. And so this can be a really big value add. If you've got an electric bill that's only a couple $100 a year, prospective buyers are going to see that and say, wow, that does increase the value of the property. So it's not just about the return on investment you're getting from your own utility bill savings. It's also really important to note the added property value that comes along with installing solar as well. So one thing I like to point out, and I use this slide to do this, is that when we talk with owners that are new to solar and want to learn more, they may have a site in, let's say, Nebraska or Illinois, right? And people don't think of those states as super sunny states compared to, say, Arizona or California. That doesn't mean, though, that it isn't a good investment or even a better investment in those states that people don't view as, quote, sunny states compared to California. So we've got three examples here, one in California, one in Illinois, one in Arizona. And I'm not going to get into the details of every single one, but I want to note, if you go down to the bottom here, I want to note the payback and the IRR summaries. And what you'll notice here is that California, actually Arizona is the sunniest state, California coming in second on an average, and then Illinois obviously coming in third. But Illinois has the quickest payback and an IRR that's much better than Arizona and just below California. And the reason that is because of incentives offered by the state government there as well as the utilities. And those incentives make up for the lack of sun or less sunshine that hits the state. So the utility bill rate in Illinois is lower, and there's less production for the same size system, 35,000 fewer kilowatt hours in Illinois for the same size system as it is in California. However, because of these incentives I've outlined below, which is the SREC value and the inverter rebate, like I said, you've got a payback of 4 years. So this is just to illustrate that geography is not destiny. If you live in Alabama or you live in Illinois or Minnesota or Maine even, it doesn't mean that you shouldn't explore and find out more about solar energy. It could be a very viable investment for you, and it could be something that really makes a big difference in your bottom line. If there are people with questions about specific states or utility territories and want to know more kind of on an indicative return on investment or payback level, just shoot me an email with the contact information I provide at the end. Okay, this is the final section. We're going to talk about one case study in Illinois and then a few other items, and then we'll close up shop here. Wanted to show a case study for an extra space storage store. This is a relatively large store outside of O'Hare Airport, northwest of Chicago proper. It's a 330 kilowatt system. So the roof here was really large. I can't remember the total square footage of the facility, but we're offsetting essentially 100% of the consumption here on an annual basis with the production from the solar. And as you can see, there's still a lot of roof on both of the roof areas that you can see on the photo. This is a ballasted array. So like I said, it just sits on the roof of the building, and there's no roof penetrations at all. It just sits on there and is weighed down by the cinder blocks I mentioned earlier. The whole installation time for this large system was just about a month from when we first stepped foot on the roof. And the cost is pretty substantial. It is important to note in that it was roughly $715,000 and was paid for via cash. The return on investment is 4 years. The IRR is right around 25%. And the annual savings, utility bill savings, I should note, is $32,000. That upfront cost, though, really important to note, that's before any tax credits, incentives, cash rebates. So that is really reduced pretty substantially by more than, in this circumstance, by more than 60 to 70% by incentives. So while it is a large amount of money, once you take into account all those incentives, you get a 4-year return on investment. And again, this is Illinois. This is not a place known to be particularly sunny or have great weather, but it still makes sense there. And we've done quite a few facilities in Illinois over the last year and have almost 30 facilities under construction and to be completed this year in the state of Illinois. So definitely worth considering. Every state, every utility territory is different, and that's why it's important to talk with a contractor that knows the local area that can give you a realistic expectation on incentives and utility bill savings. Okay, so I think this is my last slide. I mentioned this 2 slides ago, but I really want to emphasize geography is not destiny here. A lot of people come to us and say, you know what, I actually had a group in Alaska come to us the other day, and because their energy cost is so high, it actually might make sense for them to do solar. But I think they assumed that it just doesn't make sense because they get a lot of snow and it's not very sunny most of the year. But I would encourage anyone who's interested to at least reach out to me or a local contractor to help you understand the economics. But a few things to consider and look out for if you are a self-storage owner, whether you own one facility or whether you own 1,000 facilities. Here are some things to take into account. And if most of these apply to you, then it's probably a really good indicator that you can expect a good investment on some of your stores. So obviously, number one, we don't want to install solar on a roof that's 30 years old, that's falling apart and leaky. You're going to have to replace that roof soon anyways, and you have to take the panels off and then reinstall them. And that's doable, but it's expensive. So we don't want to do that. So newer roofs, doesn't have to be brand new, but we want it to have a life of 10 plus years minimum moving forward. So you don't have to remove and replace the panels. Obviously, if you have a new facility, that's a great time to consider solar, whether it's under construction now or was built in the last couple of years. You know the roof is in good condition. You know the electrical is going to look good, and it's a relatively energy efficient building, very likely as well. So that's a good indicator. If you have medium to high electric bills, that's also a good sign. That means different things to different people, but people know if electric bills are a pain point for them. And if they are, you should consider energy efficiency, but after that, consider solar energy to try to get those as close to zero as possible. Number 4 is climate control. If you climate condition your buildings, if they're multi-story climate conditioned facilities, solar energy is very likely a good idea for you. Paired with that, if you have a high electricity cost per unit, meaning, the electricity costs, for example, in Colorado are pretty low, some of the lowest in the country, but if you're in New York City, they're incredibly high, sometimes 2 to 3 times as high, or even Hawaii, which is even higher. So if you have a high cost per kilowatt hour, that's a good idea. 6 and 7, if you have a tax liability, there's a lot of customers in self-storage that are real estate investment trusts, which don't have a tax liability. There are ways to get around that, but I would say, if you pay taxes, that's a good sign, because then you can take advantage of the tax credit and some of the other incentives, whereas some real estate investment trusts can't do that. And number 7, finally, is if you are a single site owner, you can still invest in solar, and that may be a great option for you. But it gets really interesting when you have a portfolio, whether that's 5 or 7 sites or 50 or 1,000. You can really get some economies of scale and reduced pricing if you invest in a portfolio of sites. I would say the average portfolio we do is in the 10 to 30 site range, but any multi-site portfolio is going to benefit you because you're going to have a lower installation cost from the contractor, at least you should. So those 7, they're not all of them, but if most of those apply to you, I would really encourage you to consider solar energy. The industry is growing very rapidly, and it's only expected to do so further in the next year. And I encourage you, again, no matter where you are, to reach out to me or a local contractor to find out more about whether it's feasible for you and it's a good fit. It's not a good fit for everyone, but we're doing a lot of work with self-storage owners, and we think that they're starting to understand the value proposition more and more. So I'd encourage you to reach out. I think that's all I have. I'll go to the next slide. There's my contact information. You can call me or email me, and happy to answer any questions you have or provide some initial feasibility for any sites that you have under ownership. I appreciate everyone looping in, and hope everyone is staying well during the pandemic, and I'll send it back to Jenny.
Thank you so much, Matt. Gosh, great information. I tell you, a lot of things to consider. So lots of food for thought for those of us as we learn to work through these remarkable times. I hope that you've learned as much as I have today, and also hope that you'll give Matt a call, at least to investigate if solar energy is right for you. As a side note, SSA's April magazine cover story is solar energy, and some of the folks at Pivot Energy were interviewed for that. So just go to our website at www.selfstorage.org and search magazine. You'll take a look at the April magazine. There's even more detail in that article. So again, it's certainly something to consider, and hope you all will give Matt a call. In the meantime, stay tuned for our next webinar in the series. Just as soon as it's available, we'll introduce that to you, but we'll also make this webinar available on our website at www.selfstorage.org. Again, thanks for joining us today.